Hello guys, welcome back to PS Tutorials. So in this session, we're gonna learn about value of a polynomial, zeros of a polynomial, and we will also learn factor and remainder theorem. So let's start with today's session with next topic, that is value of a polynomial. Now, what do you mean by value of a polynomial? It is very easy. So the value of a polynomial px. Okay, so a polynomial px, it is given in the question. So for a polynomial px, its value when x equals to a is just obtained by putting x equals to a in px, and you will denote it by pa. So you just have to replace x over here with the value of x, that is a, and you will get a new polynomial, and it is denoted by pa. So pa is a value of polynomial px at x equals to a. So let's do one example on the value of polynomial, and then it will be more clear to you. So first example is, you can take, like for example, px is a polynomial and it is of type 3x square minus 5x plus 6. It is a polynomial. Okay, it is a quadratic polynomial. Even you can identify the type of polynomial. So now the question is that you have to find the value of p at x equals to 2. So see, I have written 2 over here. I have replaced this x by a number, that is 2. So this is a new polynomial. So you have to calculate value of polynomial px when x is equals to 2. When x is equals to 2. This you have to calculate. So how you will get p2? So just replace x by 2. Wherever x is present, you have to write 2. And then you have to calculate its value. So here you will get 12 minus 10 plus 6, that is 8. So value of polynomial px at x equals to 2 is 8. This is the value of a polynomial. So similarly, you can calculate for more values. So you can calculate for 3 also. You can calculate for negative numbers also, like -1. Okay, you can calculate this polynomial also. So you can calculate value of a polynomial for many different type of numbers. Okay, so this is value of a polynomial. Now, second is zeros of a polynomial. So this is also very easy. So like for example, if px is our polynomial, okay, hamara polynomial px, this is our polynomial which is given to us. And if we are replacing x by a, agar hum x ki jagah a likh rahe hain, okay, and the new polynomial which we are getting, it is nothing but a 0. Okay, so when you are putting x equals to a in this polynomial, when you will put x equals to a, so what you are getting? You are getting 0 as your answer. So this means that a is known as the 0 of polynomial px. So this a is the 0 of polynomial px. Okay, so whatever number, so the number for which you are getting the value of polynomial as 0, so that number is known as the 0 of a polynomial. Okay, that number is known as the 0 of a polynomial. So for example, let's do one question over here. Okay, so if I am writing a polynomial, so they will always give you a polynomial for which they will ask you regarding the zeros, or they may ask you regarding any value of a polynomial. So which type of polynomial is this? Can you identify? It is a cubic polynomial. It is a cubic polynomial because its degree is 3. So it's a cubic polynomial. So now let's calculate. So let's calculate p, value of polynomial at 2 when x equals to 2. So it is very simple. Just replace x by 2. So it is 2 cube plus 2 times 2 square minus 5 times 2 minus 6. Yeah. Okay, so here you will get 8 plus 8 minus 10 and minus 6. So see, when you will simplify, you will get a 0. Okay, so when you have replaced this x by 2, then the value of polynomial P2 is 0. So this implies that 2 is a 0 of polynomial. 2 is a 0 of polynomial Px. Okay, so in this way, you have identified the 0 of a polynomial. So 2 is a 0 of polynomial. Okay, so if you are replacing x by any number and the value which you are getting is 0, so then that value 2, that this number that you have replaced, this will be the 0 of polynomial Px. It is known as the 0 of polynomial. Okay, so similarly, you can check for many other polynomials also. So for example, in the same polynomial, so let's check for one more number. Okay, and let's find out that will be the 0 of polynomial or it will not be the 0 of polynomial. So I will take some other number. So for example, okay, let's put 0. Let's calculate at 0. So if I am putting 0, then here it will be 0, 0, 0, but the overall answer is -6. Okay, so 0 number is not a 0. 0 is not a 0 of polynomial Px. So when you are calculating zeros of a polynomial, it doesn't mean that 0 will be the 0 of polynomial. No. In this case, when we have calculated polynomial, value of polynomial at x equals to 0, so what we are getting? We are getting -6. Okay, that is a constant polynomial. So 0 is not a 0 of Px. Okay, so 0 is not the 0 of Px. Yeah. Okay then. So now here comes few important observations. Okay, so these are very important. So you can write these observations in your notebook. So first is that a constant polynomial does not have any zero. You remember constant polynomial we learned in our previous session. So constant polynomial means like if Px is my polynomial and I am writing it as -4. So this is a constant polynomial. Okay, so constant polynomial, they will not have any zero. So they are not having any zeros. You can see here, if you will calculate value of this polynomial at x equals to 2, then also you will get -4. So it's a constant value. Okay, it's a constant. So constant of a polynomial does not have any zeros. You will not get any zero. This is our first observation. Now, second observation. Second is that every linear polynomial has one and only one zero. Linear polynomial means polynomial of this type. Like if p of x is 5x plus 4. This is our 2. Okay, this is our linear polynomial. Okay. So a polynomial can have repeated zeros. Okay, it may be a case that you are getting 2 zeros of a polynomial, but those 2 zeros are same. They will hold same value. Okay, it is possible. So a polynomial can have repeated zeros are also possible. Okay, but the most important point is the fourth one, that number of zeros of a polynomial cannot exceed its degree. Remember this. Okay, so like now the question is that how many zeros can a polynomial hold? So number of zeros of a polynomial cannot exceed its degree. So whatever will be the degree of the polynomial, only that much zeros will be there for that polynomial. If it is a linear polynomial, then only 1 0. 1 0 will be there. If it is a quadratic, then maximum 2 zeros will be there. If it is a cubic, then maximum 3 zeros will be there. Okay. So for the cubic polynomial, you will never have 4 zeros. Never. Okay. So number of zeros will not be greater than the degree of polynomial. Number of zeros will not be greater than the degree of its polynomial. So this is the most important point that you should remember. It is very important. Okay, so I will repeat once again that number of zeros of a polynomial cannot exceed its degree. So whatever is the degree of polynomial, only that much zero, maximum number of zero that polynomial can have, not more than that. Okay, not more than that. And it is also possible that if it is a quadratic polynomial, so we know that maximum 2 zeros will be there. So maybe both the zeros are same, that is 1, 1. 2 zeros are there and both are same. So this is possible. So a polynomial can have, we call these type of zeros as repeated zeros. So a polynomial can have repeated zeros, but the total number of zeros will not exceed its degree. Okay, total number of zeros will not exceed its degree. Yes. Okay then. So now let's move to the next topic, that is our remainder theorem. So this is one of the most important part of this chapter, that is polynomial, and this is our remainder theorem. Okay, so first let's read out the statement and then we will understand that what theorem is all about. Okay then, so the statement is that let Px be a polynomial of degree 1 or more. Okay, Px is our polynomial, just a normal polynomial, but it should not be a constant polynomial. Okay, its degree should be 1, at least 1, but its degree can be greater than 1 also. Okay, and let A be any real number. What is A? A is any real number. A is any real number. So if Px, so if you are dividing your polynomial Px, with which we are dividing, with which term? With x minus a. Okay, and what is a? A is any real number. So if you are dividing polynomial Px by x minus a, then the remainder theorem says that the remainder will be PA, means value of polynomial when x equals to a. This will be the remainder. Okay, so by remainder theorem, you don't have to divide and you don't have to check. You can directly apply this result. Okay, I will repeat it once again. So if Px is a polynomial and Px is divided by x minus a, okay, where a is any real number, then the remainder of this polynomial, the remainder of this division will always be PA. So what is PA? PA is the value of polynomial Px when x equals to a. It's calculated in the same way as we have done just now in value of polynomial, this one, this section. Okay, so by this theorem, you can find the remainder. You can directly find the remainder. Okay, so I will now take one example and we will now understand that how we will make use of the remainder theorem. Okay, now, so you have to, so the question is that find the remainder. So you have to find the remainder when the polynomial Px, so I will write here the polynomial for you. Px is x to the power 4 plus 2x cubed minus 3x square plus x minus 1. This is our polynomial. So if this polynomial is divided by, gx, so gx is another polynomial and it is equals to x minus 2. Okay, so now let's compare this theorem with this example. So see, Px, they have given us a polynomial. Okay, now, and we are dividing by, it is now here they have written that Px is divided by, यहाँ पे x minus a है. Okay, so can you compare and find the value of a? Yes, so a is equals to 2. Yes, very good. A is equals to 2. So value of a is 2. Okay, you can compare and you can get the value. So now if you will divide this polynomial Px with x minus 2, then according to the remainder theorem, what should be your remainder? What should be your remainder? That is PA. So means our remainder will be P, and the value of this polynomial when x equals to a and a is 2 means we are supposed to calculate this value of polynomial when x equals to 2. So let's calculate this. Now, first of all, px. So let's first write our polynomial. It's x to the power 4, 2x cubed, 3x squared plus x minus 1. And now value of this polynomial when x equals to 2. Okay. So it is 2 to the power 4 plus 2 into 2 to the power cube minus 3 into 2 to the power square plus 2 minus 1. So here you will get 16 plus 16 minus 12 plus 2 minus 1. So that is 21, and this is the remainder. See, we have calculated remainder so quickly. So either you can divide and you can find the remainder. Okay, that is a very lengthy process, or you can make use of this remainder theorem. Okay, so again I will explain you. So remainder theorem says that if px is your polynomial of degree 1 or more than 1, okay, and a is any real number. So for example, here a is 2, okay, a is any real number. So this number, it's a real number, so it can be positive also, negative also, rational, irrational, it can be anything, okay, because it's a real number. So now if you are dividing this polynomial by x minus a, so from here you will get the value of a. So see, I have calculated the value of a from here. It is x minus 2. So means 2 is a. So the remainder will be PA. So now you can simply calculate the value of the same polynomial at x equals to 2, and you will get the remainder. Okay, you will get the remainder. So you don't have to divide, and you don't have to check your answer, and then you don't have to find the remainder after doing the division. You can just find the value of polynomial at when this x equals to a. Okay, so you can find the value. So this was all remainder theorem. Now, the next theorem is factor theorem, and this is the last theorem of this unit. Yes, factor theorem. This is also very simple. Okay, so first, let me tell you that which numbers are known as factors. Okay, so you know that like 2 times 3, this will give you 6. Okay, so these numbers 2 and 3, they are known as factors. These are the factors. Okay, so if you will divide 6 by 2, then you will get 3, and if you will divide 6 by 3, then you will get 2. But surely, what do you think about their remainders? Their remainders will be 0 in both the cases. So if you are dividing any number by its factors, then the remainder you will get will be 0 always. So if you are dividing any number by its factor, then you will get remainder as 0. Okay, so this concept is needed while doing factor theorem. So now let's read the definition and understand the points mentioned in this theorem. So factor theorem, it states that let Px be a polynomial. So Px is any polynomial, so it is of degree 1 or more than 1. And here also A is a real number. A is what? A is any real number. It's any real number. Now, so first point is that if P of A is 0, now you remember that if Px is our polynomial and A is any real number. So if you will divide this polynomial by x minus a, then P of A will be your remainder. This will be your remainder. Okay, so this was remainder theorem that we have done. So factor theorem, it says that if you are getting PA as 0, PA as 0 means, PA means remainder is 0. So if you are getting PA as 0, then this means that x minus a will be the factor factor of px. So x minus a will be the factor of polynomial px. Okay, so here you are making use of factors. So if PA is 0, and we know that PA is the remainder. So if remainder is 0, that means that numbers are fully divided. Okay, you are not left with any remainder. Okay, so if remainder is 0, then that x minus a will be the factor of polynomial. Okay. And the second statement is the converse, that if x minus a is the factor of polynomial px, then surely its remainder is 0, then PA is 0. So you can make use of these two statements, okay, and you can find the factors. So what is a factor? So in case of polynomial, factor will be x minus a, because we are dividing our polynomial by x minus a. Okay, so if the remainder is 0, then x minus a will be the factor. And if converse of this, just opposite of this statement, that if x minus a is the factor, then p of a is 0. Polynomial of a will be 0. Okay, value of polynomial at x equals to a will be 0. So this is our factor theorem. Now let's practice few examples based on this, then it will be more clear to you. Okay, so let's take one example. So you have to show that 2x minus 3 is a factor. It is a factor of a polynomial x plus 2x cubed minus 9x squared plus 12. Okay, so you have to show, this is your question, you have to show that it is a factor, 2x minus 3. Now let's go to the factor theorem. So if you have to show that x minus a is a factor, then what you are supposed to do? So, okay, so you are supposed to show that if p of a is 0, means value of polynomial at x equals to a is 0, then x minus a is a factor. So we will use this first point. Okay, now so let us suppose that this gx is our polynomial, that is 2x minus 3. Now so if g of x is 0, then this means that 2x minus 3 is 0, and from here we can calculate value of x equals to 3 by 2, right? So from here we have calculated the value of x is 3 by 2. Okay, or you can write in this way that x minus 3 by 2 is 0. So what is a? So a equals to 3 by 2. This is our a. This is our a. Okay, so we have calculated x minus a. So first you should calculate this a. This a is very important, this a. Okay, so now if you are getting, so this px is what? Px is our polynomial. This is our polynomial. Okay, if you are getting p 3 by 2 as 0, then this will be the factor. So now let's calculate. So we will calculate p, value of this polynomial at 3 over 2. So this you will get as 2 multiplied by 3 by 2 cube minus 9 multiplied by 3 by 2 square plus 3 by 2 plus 12. Okay, so now let's simplify this and let's get your answer. So here you will get 27 by 8. And here you will get 9 over 4. Here you will get 3 over 2 plus 12 as it is. Okay, and then what you can do? First you multiply all the terms. So it will be 4, 81 by 4 again, and 3 by 2 and 12 as it is. Okay, so now you can take the LCM. So when you will take the LCM, you will get it as 0 over 4. So this is equals to 0. Okay, so see, the value of polynomial at x equals to 3/2 is coming out to be 0. So this means that 2x minus 3 is a factor. It is a factor of px, is a factor of polynomial px. Okay, so make use of factor theorem. So this factor theorem is very easy. Okay, so in this question we use this first point. Okay, we have used this first point that if p of a is 0, then x minus a will be a factor of px. So we have shown that p of a is 0 here. So first we have calculated a, and then we have shown that p of a is 0. So then it is a factor. Okay, now, so similarly, you can make use of the second point also. That is, if x minus a is a factor of px, then for sure you will get remainder as 0. And remainder is pa according to the remainder theorem. And pa is equals to 0. Okay, so always you will get it as 0. So you can make use of factor theorem and you can make use of remainder theorem, and then you can find your factors and you can find your remainders without doing actual division. Okay, so for factor and remainder theorem, so first you should know that how you can find the value of a polynomial. So for the value of any polynomial, just replace the variable in the polynomial with that number, and you will get the value of polynomial. So thank you guys for watching these videos. And for the next unit, please subscribe to my channel. Okay, so have a good day. Goodbye.